Hi, my name is Shantanu. Here we are going to design a mat footing for 16 columns. Firstly, we have created a new model. In new model, we have given clear cover of 50 mm, bar size 22 mm, and selected grid only option. So firstly, we have to define materials. We have defined HYSD 4 and 5. So we have to give these values: weight per unit volume, modulus of elasticity. Weight per unit volume is 77, modulus of elasticity E is equal to 2 into 10 raised to 5, Fy 415 and Fu 485. Okay, then for M40, give material type as concrete, then weight per unit volume is 25, modulus of elasticity is 27386, Poisson's ratio U is 0.2, and coefficient of thermal expansion is 0.0000055. Then FCK is taken as 40. Okay, then go to define slab properties. Type here the name, property name mat footing, and slab material as M40. Select type as mat and give firstly thickness as per given 600 mm. Then click on OK. Then click on define column properties and create a new property and give property name column 500 by 500, material as M40, column shape as rectangular, and give the dimensions here 500 by 500, and then click on OK. Similarly, add second column of 600 by 600. Okay, then go to define, click on soil subgrade properties, type name here soil 1, and subgrade modulus we have calculated 3E plus 0.04, and click on OK. Then also check for load patterns, check whether these options are added or not, dead load and live load. Check for load cases, we have added as linear static for both, and then go to load combinations, create combination first, type name, then give here scale factor 1.5 for dead load and live load for both, and select here design selection as strength ultimate, only select this option and then click on OK. Similarly, create add new combo, give name combo 2 and select scale factor as 1 for dead and live load, and select other three options: service normal, service initial and service long term, then click on OK. Then we have to draw slab areas. So for this, go to draw, draw slab areas, select the property mat footing here, and then by clicking on first this column, then a line appears, and then select this, then this, then this, and lastly finish on the firstly selected column and click. Now we have to extend our area for 2 meter outside. For this, click on area of the footing and then go to edit, go to edit areas, and then click on expand or shrink areas. Type here the value 2000 and then click on OK. Our area will expand by 2000 mm from all sides. So to draw columns, go to draw columns, select here the property below, property below as none, property above as 500 by 500, and then height below is 0, and height above as 2 meter. Then place these columns firstly here, then here, on all sides, and similarly place middle columns by changing dimensions into 600 by 600. We have to design the strips now. So for this, go to draw design strips, select here the layers. Here layer A is selected. Here start width left right and end width left right is selected 1.5, and for this go to this point and select this point up to this, then right click on outside and similarly draw all sides. Then go to strip layer B. Now draw vertically. After drawing vertically, click on outside the area for escaping. Now we have to assign the properties. So select the area of footing, then go to assign, go to support data, then go to soil properties, and here add new property, and subgrade modulus as 3e plus 04 we have added already. Now we are going to apply the loads on each column. For this, select column, then go to assign, go to load data, point loads, select whether lead or live load is to be applied. Here type the value of some kilonewton defined, and give here the size of load for punching shear, that is the size of column generally. Give x and y dimensions and click on OK. Similarly, apply live loads. In this way, apply dead load and live loads on each column by going to assign, go to load data and going to point loads. Here we have to add dead load, live load value for gravity minus z and xy dimensions and click on OK. Now we are going to assign the materials here. So firstly select whole area of foundation by right click on it, and then go to design, select here HYSD 415, then click on OK. Similarly, for each strip, here we have 8 strips, 4 in x direction and 4 in y direction. So click on each strip and select here HYSD 415, then click on OK. Now we have assigned the materials and their properties. So go to run analysis. So the displacement is shown here. Then go to run analysis and design. then go to display and show punching shear design. Here I have applied the thickness of slab as 1600 mm. Firstly it was 600 mm, so I keep it reiterating, and these values have come. So these values are less than 1, so the punching shear design is safe now, so there is no punching shear failure. Now for seeing the exact view, actual view, go to 3D view first, and then go to extrude view here, so we can see the actual view of matte foundation. Similarly, go to display, then show strip forces, show reaction forces. Select the load cases, dead load or live load. Similarly, load combinations 1 and 2, and these options, and click on apply, so that we can see the forces. Similarly, go to show strip forces, and click on dead or live load and check combination 1 or 2, then apply the component as movement, axial force, force or torsion. And click here to show values on diagram. Suppose we are taking the moment component, here the moment is shown. Then come to XY plane. Similarly, go to display, show slab forces or stresses. Select load case and combination, and here maximum moment or maximum shear force is selected. Suppose maximum moment is selected, then click on apply. The moment is shown here. Click on display and click on show crack widths, and select load case and combinations. Click on apply to see these crack widths. You can see here these crack widths. In this way we can see also the crack location also, slab bottom face and slab top face. Because we are going to see slab top faces, and go to apply. Here the crack widths are shown. Then click on run detailing. Select these 3 options and click on OK. So here results are here available. And go to Model Explorer, drawing component views, go to slab views, and go to rebar table. So here we can see the bar mark, diameter, shape code, cut length, numbers, and total length of each bar. Similarly, we can see bar schedule, rebar schedule, and bill of quantities. This length and weight in metric ton is shown. Total weight is 28.18 metric. Go to individual slab views, then go to mat 1. And select the rebar plan. We can see various reinforcements. Similarly, select different options for different type of results. Top rebar plan, bottom rebar plan for all bars. Section 1, section 2, reinforcement profile for layer A and for layer B. Similarly, drawing sheets can be seen. So this was the matte foundation design. Thank you very much.